We have seen how we can use R notebooks to combine R Markdown and code in order to create documents that include statistical analysis as well as the narrative to explain what we're seeing in the output. In this video, I want to take a little bit deeper dive into how we can communicate in R and with R notebooks, R Markdown, and I want to tell you about the genesis of R Markdown. This is historically interesting, but that's not the only reason I'm telling you about this. R Markdown actually permits you to include TeX and LaTeX commands, and so I want to tell you about these markup languages. Let's start with TeX, because that's where it all got started. TeX is a typesetting system that was written by Donald Knuth and released in 1978. Donald Knuth is a giant in the field of computer science. He is probably considered by most to be the grandfather of much of what is now in modern computer science. He was a professor at Stanford University. He retired from there when he was in his 50s, but continued to develop many applications and algorithms that are still used today in computer science. He is the inventor of the TeX typesetting system. I read an interview with Donald Knuth about 6 or 8 months ago in the New York Times. He's now in his 80s and is working on a large multi-volume set about every aspect of computer science. The purposes of TeX are to produce highly aesthetic books and manuscripts with no typesetting experience, and to produce identical documents regardless of the computer and operating system. Donald Knuth's idea was that individuals who want to create attractive documents should not have to gain experience in such things as fonts and layout, but rather the computer should be able to do this for them. So that's the purpose of TeX. The author can focus on content, and TeX will focus on presenting that content. TeX is free, and the official implementation of TeX is maintained by the TUG, which stands for TeX Users Group. Now, most people who use TeX, including myself, actually use LaTeX, which is a document preparation system that is a collection of TeX macros. That is, LaTeX does not work without TeX. It simply assembles various commands in TeX into macros that we most frequently use. It makes it a lot easier to use TeX by calling on these macros. This was written by Leslie Lamport and released in 1984, which is 6 years after Donald Knuth released TeX. The purpose is to make TeX easy to use when preparing common types of documents. The input for both TeX and LaTeX is a plain text file with content and markup. This is a very important feature, and I'm going to emphasize this in later videos when we talk about reproducible research. R Markdown is also constructed in a plain text file. Now, if you're not sure what I mean by that, let me show you. Here is a Microsoft Word document. If you're looking at this and saying, that doesn't look like a Word document to me, that's because I'm looking at the file with a plain text reader. That is, we are looking at each bit in the document and what those bits look like. If I were to open this in Microsoft Word, of course you would see text that you would be able to read. It would look like what you expect with a Word document. Why? Because Microsoft Word is translating this into a language that you can understand. Word saves all of its Word documents in a format that is only known to Word. And so when we try to look at the individual bits, this is what we see. Similarly, if I were to look at an Excel document, here's what we would see. That's because Excel saves all the data in a format that is an Excel format, not a plain text format. Now, when I take an Excel file and change it to a CSV file, then it becomes plain text. I'm going to show you this exact same data that you're seeing in this Excel file as a CSV file. This is a plain text file. Plain text means that every bit appears as standard text and not in any proprietary format like Word documents and Excel documents. So when we use TeX or LaTeX, they are in a plain text format. Here is my syllabus for this course. It is written in LaTeX, and you can see that this is a plain text file. You can read everything. The so-called code is actually in text. So here is a line of code, just as if we were creating code in an R code chunk in an R notebook. These are the commands, but the commands are written and saved as text files. There are many advantages to using non-proprietary files when doing reproducible research. Every bit is saved in a format that anyone can read. When I write R code and save it, it saves it as a text file. If I were to look at SPSS or SAS functions, they would be in a format that you could not read with a text editor the way you can read R code. I can write R code right within any kind of text editor. It doesn't need to be in RStudio. So this LaTeX code, which is written in standard text, is converted into this when it runs through the processor. That's very much like our R code when we submit it to R. Our R code is in plain text, and it is read by R and converted into output. I created this syllabus with plain text, but then I ran it through the LaTeX processor, which itself runs things through the TeX processor, and then it converts to this document. I don't need any special software to read the code. I can simply read it in any sort of text editor. When we work on our projects, we're always going to use text files. I sometimes call these flat files because people think of text files as writing narrative, whereas a flat file you can think of as text, numbers, such as in a CSV file, any type of file in which I call it up in a text editor and I can read it. LaTeX editors make it easier to add markup and preview results. I use a LaTeX editor, and what that allows me to do is work with my standard text file, but I can click on icons that automatically insert LaTeX commands so that I don't have to memorize them all. LaTeX is free. The official implementation of LaTeX is maintained by the LaTeX project. So why am I telling you this? For two reasons. One is LaTeX is a predecessor of R Markdown. R Markdown is based on many of the same principles that came from LaTeX, which in turn was based on TeX. The second reason I'm telling you this is because LaTeX can actually do more than R Markdown. If we want to put something in our R Markdown document and do not have R Markdown commands to do it exactly the way we want, we can resort to LaTeX within an R Markdown document. The most common example of this is when we write equations in R Markdown. It actually uses LaTeX to write equations. So if you don't have what you need in terms of R Markdown documentation for equations, but look for the documentation under LaTeX, you can find exactly what to do. Some aspects of LaTeX are integrated into R Markdown, and when R Markdown doesn't give us what we want, we can look up the LaTeX command, put it in our R Markdown document, and do exactly what we need. There's an intermediate step between LaTeX and R Markdown in terms of development, and that is Markdown. TeX and LaTeX are considered markup languages. So Markdown is really a play on the word markup. Markdown is a lightweight markup language developed by John Gruber and released in 2004. John Gruber's idea was LaTeX is very powerful, but most people don't need all the features of LaTeX. So he decided he would create a markup language that he called Markdown that was lightweight, that was like LaTeX and used much of the same syntax as LaTeX, but only contained those features that people need 90 or 95% of the time. In so doing, it makes it much easier to learn, yet you can do the same sorts of things that you can do with LaTeX. This was extended into now what is the most common Markdown, and that is Pandox Markdown, or just Pandoc. This was written based upon John Gruber's Markdown, but extended it so that you could do a bit more, but still not have to learn all of LaTeX to do it. R Markdown is actually based on Pandox Markdown, so if you're ever needing something in R Markdown and not sure how to do it, and you look it up in Pandox Markdown, you can figure out how. The key goal is to promote the quick creation of highly readable documents. Markdown is a language that is implemented in multiple development environments, including RStudio, in the form of R Markdown. Markdown, as I mentioned, can be extended with both LaTeX and TeX. That is, you can use LaTeX and TeX commands within Markdown if it doesn't give you everything that you need. The official version of Markdown is published at this website, and the official version of Pandoc is published at this website, which I link to on our Blackboard site. Finally, that brings us to R Markdown and R Notebooks. R Markdown is an implementation of Markdown and Pandoc that is implemented in RStudio. It has the same purpose, to create attractive documents, but to do so in conjunction with output from R scripts. R notebooks are files that contain R Markdown and, as you know, R code chunks. So the notebooks contain three elements: a header, the YAML, to document the notebook and indicate the type of output, R code chunks, and then text with Markdown formatting. Our notebooks produce many types of output, including web pages, PDFs, Microsoft Word documents, and R package vignettes.